Okay, guys, so this one thought we did quite well. Just let me give you a quick visual on this. One of the ways you could do this is to say that squared simply means that base is being multiplied times itself. And so you could expand this out to be 2 root 3 times 2 root 3. You can multiply the two 2's together. And, of course, 2 times 2 is 4. And then the square root of 3 times the square root of 3 would be the square root of 9. And we probably remember that 9 is a perfect square. And so the square root of 9 is 3. 4 times 3 gives us 12 for an answer. Okay, good warm-up. You guys did well with that one? Okay, cool. Well, then let's take a look at another one. Let's do... let's do this one. Let's go with 3 root 8 times 2 root 5. 3 root 8 times 2 times the square root of 5. Make sure you simplify this one all the way down after you've done the multiplication. All right, Joel, that's a good answer. Connor, well done. All right, Jake, you got it. Yep. You should have skipped class. I was in China, so she wanted me to fly back every night. Do you eat McDonald's there? You sound very good.
I heard you say that too.
All right. Again, want to just give you a visual on this one. When you multiply like this, we're going to multiply the 3 times the 2 because those are both non-radical numbers. 3 times 2, of course, is 6. And then the two radicals can be combined by multiplication as well. Of course, 8 times 5 is 40. So 6 root 40 would be a really good answer. It's just not simplified all the way. So in order to make sure this is simplified, we need to do the prime factors of 40 and look for those pairs of like factors. So 40 is really 2 times 2 times 2 times 5. And there's a pair of 2's. Those come out as a single 2. So it would be 6 times 2 times the square root of 2 times 5. And of course, 6 times 2 is 12. So I saw this on just about everybody's work. 12 root 10 was our final simplification there. All right, do you guys have any questions at all? I want to do one more warm-up. Okay, so let's do this then. Let me get this up here. Go ahead and jump back up to the board. Grab your whiteboard, and we'll do this one right here.
Let's go for it. I gotta move.
Oh, it's 18. Oh, gosh. Did you finish your project?
Wait, what?
Did you? I'm not sure to print it out, though. It should be an issue. Oh my gosh. Big.
Did I get it right?
Nice job.
You're just so funny.
Nice job.
I got it wrong.
I think what you did here, what you did is you forgot the 3 and the 5 were already there.
Oh, you just multiply that.
Yeah, they don't disappear. So it'd be, basically be this times this, and this times that, and that's gonna change. Yep, that'll change that. Ron, it looks like you're on your way there. Good job. All right, Anna, Avery, looks good there. You're on your way, Kendall. Emily, that's good work. It's really good, excellent work shown there. All right, feeling good about this? Awesome, you did the same thing, looks like you did. Nice work.
My writing compared to hers, jeez.
Hers is way better than yours, isn't it?
I write
I'm
humongous
just
when it comes to
messing with
math.
you. I think you both have about the same neatness. Hers is just a little more compact, right?
Yeah.
Hey, you both fit it on the page. That's the main thing, right? Keep going there, Paige. Let me know if you need
I
some
filled
help.
up like 3 whole pages.
All right, Luke, that's looking good. Connor, did you get this one?
Yeah, you did.
I did. Okay, I worked my way around the room and forgot. I'm sorry. All right, Grace, that looks good.
Wait, what am I looking at? I didn't No, I read it wrong too. Yeah, just kind of.
All right, so guys, listen up, please. Just to again give you a visual here. Root 8 is really square root of 2 times 2 times 2. When you break down into prime factors, 18 is really 3 times 3 times 2. So you got a pair of 2's that come out as a single 2, 6 root 2. And you got a pair of 3's that come out as a single 3. So 3 times 5 is 15. And when you add these up, you add them like they're like terms, like we used to do with polynomials. 6 and 15 added together is 21. You keep the radical the same, 21 root 2. So there's a little change of pace there, right? Because we did multiplication a couple times. I threw an addition problem at you. And I think for the most part, we navigated that really well. So great job. Do you guys have any follow-up or final questions before we move on to our topic of the day? We're all good? Okay, awesome. So if you guys have not already done this, grab your notes. And we are going to look at our final several examples in 8.4, I think it is. Yes, so we should be right here. We're going to do a lot of these together. You might not have talents in the throwing sports, Grace. I don't know. We'll see. At least that's not evidence of it.
Yeah.
Yeah. So that was a really nice way of saying just walk it up there.
I bet I can make this.
Probably Grace. Oh, Grace. Learn your lesson after the first time. There we go. Thank you very much. Okay. So guys, in your notes, we're gonna work through these first 4 examples together. Send you the board. We'll do some more practicing. Okay. See how you're doing. All right. So when you look at number 8, what jumps out at you? Something should. Say again? Parentheses for sure. What else about the parentheses? What pattern do you guys see developing? It's a distributive property. Do you see it? Hey, it's a distributive property. I know you're glad he's back, but I'm going to ask that you maintain focus. Thank you. All right. So, square root of 11 being distributed in there. You could even draw these in if you wanted to. So let's look at it from this perspective. So it'd be the square root of 11 times the square root of 11 minus 2 times the square root of 11 as I distribute. So the square root of 11 times the square root of 11 would be the square root of 121. This would just remain 2 times the square root of 11. And then this would be hopefully where that little table or maybe your knowledge from past classes would help you. 121, of course, is a perfect square. It's 11 squared. And so this would end up being 11 minus 2 times the square root of 11. That is the answer. Say again?
Never mind, because 11 is good. So you can't like subtract those two.
Right.
Can't subtract 11 and 2?
Hey guys, hey, I apologize. So the two questions were essentially, why can't we add those together? Because of course there are two 11s, right? The answer is that this is the square root of 11, and this is an 11, and so they're not like terms essentially, right? And then the other question that came up was why couldn't we do something like this, where we say 11 minus 2 is 9, and so we end up with 9 root 11. We can't do that. Why can't we do that? Yeah. Sure, right? So 2 root 11. So I think you can look at this two different ways. What would be the implication of the fact that it's attached by multiplication? Because you're right, that's an important point. But why is that so important? PEMDAS, right? So if I were to say 11 minus 2 is 9, aren't I essentially doing the subtraction before I do the multiplication? That would be the issue. If you were going to do that, you're going out of order of operations, and you can't do that. The other way to think about it would be to look at these two terms right here and say, well, 11 is just 11. There's no radical attached to it. This is 2 root 11. So they are unlike terms, and you cannot combine unlike terms. I think you look at it both ways. Grace?
Okay, but like saying you can't do the subtraction because it comes after multiplication, that's like saying, like if it was like 1 plus 1 times times 6 or something. But like pretend you couldn't do the 1 times 6. Like could you do times negative? No, you can still do that. Well, never mind. Well, okay, but couldn't you still do 1 plus 1? Or if it was times 6x. Yeah, this is good. Times 6x. Okay, you can still do 1 plus 1, even though.
PEMDAS.
But
So there's no, if we were going to try to simplify what you just said, there's no parentheses. There's no work in the parentheses to be done. There's no exponents to be done. Multiplication would come next. What's 1 times 6?
6.
Not this.
Okay, but it's 6x. So I thought
No.
it's connected to the x, the 11's connected to the square root. Never mind. Okay.
Yeah, you got to follow PEMDAS. I mean, your questions are really good, and I'm definitely willing to explore it, but I think I've answered it, right?
Yeah.
Yeah, I definitely will hear you out. I think it's a good question. Okay. All right, so now let's do one that is a little more complicated. Do you guys see in number 9, isn't it again just a distributive property? But it's a more complicated distributive property, no doubt. So what we're going to do is take a similar approach to this. Let's see here. I want to do this and this, maybe. Yeah, there we go. So take a look at number 9. It's 8 times the square root of 3n, parentheses, root n plus 3 root 3. There's a lot of radicals and a lot of non-radicals going on up there. So I'm going to do my best to stay as organized as possible. And here's my attempt at that. I'm going to go ahead and draw in these little distributive marks like that. And I'm just going to write it out for what it is. Let's remember that the distributive property is essentially a multiplication. So I'm going to write this out as 8 root 3n times root n plus, and I'll get the next term in there in a second. But you see all I've really done here is I've multiplied this times that. And then in just a second, I'll multiply the 8 root 3n times the other term. Make sense? Okay. So then when I multiply on that second part of the distributive property, it'll be 8 root 3n times 3 root 3. So all I've done, you can see perhaps in both these terms, I have distributed this to both. It's still a distributive property. And details that follow are a little more complicated, but it's still just a distributive property. Look at what I've got there. Let me know if you have a question. Kind of like Grace. I mean, you could hear Grace like trying to like work it through in her mind. She's like, but what about, oh, no, but what about, okay, and she had a question. If you're doing the same thing, feel free to voice it, okay? Okay? All right, we're good. So then as we finish this out, what I'm going to do is look at each one of these terms, term by term, and see if I can multiply and simplify here. So as I look at the first term, do you guys see how there is just the 8 right there? There's not a non-radical for me to multiply by. The 8 is just going to remain an 8. But the root 3n times n, those are both radicals, so we can multiply the radicals together. So what's 3n times n?
3n squared.
3n squared. So this would be 8 root 3n squared. Plus, now in the other term, there's a little bit more going on. So I've got an 8 and a 3. Those are both non-radicals. So 8 times 3, I can multiply those together, and I get 24. And then I also have some radicals I can multiply together. I've got root 3n and root 3. So what is 3n times 3? 9n. There we go. So it would be root 9n. I'm trying to break this down into really small steps for us, and we're almost done. So let's take a look at the radicals here. We're always supposed to look to see if we can simplify. And, we can break this down as far as you want. I'm looking at this radical on the left. Is there anything inside the radical that could come out? Yeah, there's 2 n's in there, right? There's an n times an n squared. So couldn't that come out as a single n? So I would write it like this. It would be 8n. But then there's just a single 3. Does this make sense?
Yeah.
N squared is just n times n. Yes, sir?
Why is there not another? Because there's 2 and...
So, yeah, you're probably going to go back and check your videos out. The prime factors of n squared would be n times n. And while we're at it, why don't I just do this other one here too? The prime factors of 9 would be 3 times 3.
So it's 72.
So the rule is, Alec, if you have inside a radical, if you have a pair of like factors, so in other words like 2 n's or 2 3's like we have up here, then to get them out of the radical, it's going to go from 2 of them to 1 of them. The reason being, like, it's easier to see over here. Like, intuitively, do you know what the square root of 9 is? 3. So there's 2 3's in there. So to get those out of the radical, you have to do the square root of them. So the square root of 3 times 3 is 3. So 2 3's on the inside is going to give you 1 3 on the outside. Okay? So then to finish this off with that, you'd go 8n. There's that 1n that came out. It's really both of them came out, but they come out as just a single. And then the root 3 is left over. Plus, I've got 2 3's. They can come out as a single 3. Multiply times the 24, though. Do you guys know what 24 times 3 is? So it'd be 72. And then the n is left over in there. And that would be your final simplification. If you got to this step right here or this step right here, you've done a ton of good work. You just didn't simplify it. Get a lot of credit if you did that. Hopefully you'd see to simplify it all the way. Okay. How's everybody doing? There's plenty going on with these for sure. We can do a couple more here, and then we'll be to the board practicing, okay? So take a look at number 10. Number 8 and number 9 were both distributive properties. What do you all see on number 10? You should see FOIL, right? It's a binomial times a binomial. Root 3x minus 5 times root 3x plus 2. It's a FOIL. So let's FOIL this one together. So I'm going to multiply root 3x times root 3x for my first FOIL. I don't know, what do you think? What's 3x times 3x? Yep, but it isn't a radical, right? That hasn't changed. So it'd be the square root of 9x squared. Okay, then that's our firsts. Our outers would be right there. So notice this, really important, the 2 is not in a radical, right? Whereas the root 3x is. So the way we would write this is plus just 2 root 3x. I can't multiply that 2 times the 3x because one's in a radical and the other one is not. It'll just be 2 root 3x. Now so far we've done FO. Now we need to do FOIL. We've got to do the I and the L. So here's the inners. you see how the inners are kind of like the outers? There's a radical number times a non-radical number, and so it's going to multiply similarly to what we did with the outers, I guess. It'd be minus 5 root 3x. And then probably the easiest one of all is the ul in FOIL, right? That's just negative 5 times 2 minus 10. Bless you. Okay, so I'd say if you got to this point, you've done some really excellent work. Haven't simplified everything, though. There's some simplifying to be done. Anything jump out to you is, hey, we could simplify this. We could simplify that. The middle terms, right? Aren't the middle terms like terms? They're both root 3x terms. And so remember when you add these together like you did in your warm-up, you're going to be combining the coefficients and leaving the radicals the same. So anybody have an idea what the result would be if I added the two middle terms together? What do you think, Victoria? Negative 3 square root of 3x. That's right. Good job. And the minus 10 is hanging out there. There's really nothing we can do to simplify that. But what about that first term? Could we simplify that?
Yes.
We could. What's the square root of 9x squared? 3x, right? So you could look at this and say, this would be kind of the question that Alec was talking about earlier. 9 is really 3 times 3. X squared is really x times x. You see the pair of 3's and the pair of x's? They'd both come out as a single 3 and a single x. So it'd just be 3x right there. This would be it. You see how we're building slowly? We're building skill upon skill. Connor, did you have a question?
I did something different.
What'd you do?
I don't know.
Okay. Well, look it over. I'd be happy to look it over with you. I don't think there's anything else we can do simplifying wise. I'll let you ponder, okay?
Okay.
I'll come by in a second. Guys have any questions on 10? Okay, so last one here. Number 11. This one has the potential to be the most tricky. It's not. Can I show you guys something, a common misconception? What I'm about to do is wrong, not right at all, but it gets done sometimes. So please check this out, and please don't do this. It's tempting, though, isn't it? Hey, square root squared, square root squared. It's got to be it. This feels right. It's so wrong. Okay, you can't distribute a squared over a sum or a difference. You can't do that. Let me finish my thought here, Grace, just to compare and contrast this. So here's what you do. And maybe I'll tell you what. You guys have been doing this enough here. This is our fourth example. I'll let you guys try to finish this by yourselves. Well, let's remind ourselves what squared means. Squared means the base times itself. So we're going to expand this. So it's going to look like this. Square root of 23 minus the square root of x times the square root of 23 minus the square root of x. So instead of some kind of convoluted distributive property, what is this really? It's really FOIL. Okay? So expand that out and FOIL. Okay? So it lets you guys try to, this is really similar to the one we just did. So let me see if you can try to finish this out. I'll check your answer in a second. Peeking over some shoulders, kind of looking at what you have here. I think that we are most of the way there. I think we're pretty darn close. I think there's going to be, for most of you, you're going to feel like, okay, I mostly have this, but there's one thing I got to tweak. So let's go ahead and take a look at how this would go. When we FOIL this, the square root of 23 times the square root of 23 ends up being the square root, isn't it 529?
Yes.
When you multiply the 23s? Okay. And then, so that's your firsts. Your outers, you're multiplying, again, a radical times a radical. 23 times x is just 23x, so this would be minus root 23x. Really important to note here, the 23 and the x are both in the radicand. Both of those make up the radicand. It's not like the x is outside of the radical, they're both in there. So that's your firsts and outers. Your inners are going to give you the same thing as your outers, so minus root 23x. Your lasts, a negative times a negative is a positive. Square root x times x is x squared. So take a look at maybe first step that you had. If that looks like your first step, you've done FOIL really well. You've done it perfect, right? So that's awesome. That's a really good first step. You guys have any questions on that part? Okay, so now what remains, of course, is just simplifying. And I'm going to do kind of the easier simplifyings first. The square root of 529 is 23. right? We should know that because we did 23 times 23 to get there. So this is just 23. I'm going to leave this middle term pair alone for now. The square root of x squared is just x. So again, look at your work. If you got to that stage, you're still doing really well. Any questions on that stage? Simplified my first and my last. Hey, Cole. I know you can hear me. Please be quiet. We can talk about why if you want. I'm trying to be respectful. Thanks. Okay, so then as I walked around, I saw definitely the vast majority of us got to this stage correctly. Did a really nice job. Where I saw the mistake coming into play was, what do I do with that? So the most common error that I saw, and I'll erase this in a second, I saw this right here. The most common mistake I saw was to write something like, I don't know, minus root 46x. So that's definitely not correct. Okay? So here's what I want you to realize, if maybe you wrote that, is that those two terms in the middle, aren't they definitely like terms?
Yeah.
So the radical, the variables, like everything is exactly the same, right? So when you look at this right here, and you say, hey, this term and this term there are like terms, I 100% agree with you. But let's remember what you do when you add like terms together. Don't you leave the variable or the radical expression exactly the same and add the coefficients. So in other words, like 5x plus 7x, you just do 5 plus 7, right? You get 12x. If you're doing 3 root 2 plus 9 root 2, don't you just add the 3 and the 9? And you leave the root 2 the same? So when we add these two together, we are going to leave the radical the same. So this radical is just going to be root 23x. But I got to add the coefficients. So what's the coefficient on the first one? Negative 1. That's right. What's the coefficient on the second one? Negative 1. So if you add a negative 1 plus a negative 1, you get negative 2. So it'd be minus 2 root 23x. Whew, that's a tough one, right? So, hey, let me just be honest with you. If you got to this point right here and you had root 46x, you did all the stuff leading up to that right, you've done so much correct. Please don't look at it and be like, oh, I'm some kind of failure. I couldn't figure it out. You did a lot of stuff right. You really did. If we can figure out how to handle those two middle terms, obviously we'll be in better shape. Okay. All right, so we're going to do some practice at the board, see how it's all going for you. So grab a board, grab a spot at the board. Here we go. All right, ready, go. Hey guys, let's try the one up there on the screen. A little practice in here. These have been around. I've seen a few, but we just need to close this up here and finish up well. So, guys, listen up, please. Walking around, the folks that I saw did a really great job of recognizing that we need to expand this into FOIL. And so I'm going to write that out right here. I'll just erase this, and I'll write it like this. A plus root 7 times A plus root 7. I saw that on just about everybody's paper. Great job with that. And then I saw that you FOILed. So that's another really great step. Of course, A times A is A squared. Slow me down if I go too fast or if something doesn't make sense, please. A times root 7 would just be A root 7. The A is not a radical, and of course the root 7 is a radical. Similar multiplication right here. So this would be plus A root 7. And then lastly, root 7 times root 7 would be square root of 49, because those are both radicals. You can multiply the 7s together. So you look at what you have up there. So I'm looking at this. This is Alec, I think, right here. Alec has this step. It's really good. That means he expanded it correctly. He FOILed it correctly. The only thing that remains is a little simplification. And so there might be some work we need to do there. There is nothing like the a squared, so I'm just going to leave that as is. And root 49 is 7, right? Square root of 49 is 7. So I'm going to leave that alone as well. The only issues that I saw as I walked around was how do I deal with the two middle terms, right? So when you look at the two middle terms, number one, are they like?
Yes.
They are definitely like terms. They're both a root 7. So let's remember, when you are adding like terms, don't you leave the like term part totally alone. You leave it as is, and you add the coefficients. So what is the missing coefficient right there?
A 1.
It's a 1. Isn't it 1a root 7? So if you wanted to write that in there, you could. So it's 1a root 7. Isn't there a 1 right there?
Yep.
So if I've got one of them and I add another one of them, how many do I have?
2.
So it would be plus 2a root 7. That makes sense? Kendall, you got it, don't you? You're like, 2!
Yes.
Let me be heard. Okay. This will be your final answer right there. Ladies and gentlemen, before you go, don't forget that there is a intro video due for tomorrow. Okay? Make sure you get that done. Have a great day.